Welcome back, physics fans. Here is another question on forces, and we're just going to show applications of it a little bit more with, hey, more than just one object at a time. Let's take a look at this one. Okay, there is a pull force in the front, and it's being transferred by the rope. And that's what we mean transferred, because this tension is in the rope, which is going to be F pull, because it's going to be transferred all along there. So these two things are equal. It's pulling on mass 1, and then there's a rope attached to mass 1 to mass 2. So mass 1 is pulling along on mass 2. And this is a tension force in this system here between these two objects. And tension 2, which direction is it? The answer is yes. It's a tension force. It's one of the only forces that have two directions. It's basically along the rope. So according to M1, it's pulling back, and according to M2, it's pulling forward. It's kind of like a person standing in there and pulling them back and forth. So let's take a look at how to do a question like this. It's not hard. In fact, some of people probably already know what to start working on. But let's put some numbers down here. The pull force here is 50 newtons. This mass we'll make is 2 kilograms, and this mass here will make 8 kilograms. We're also going to put a force of friction in here. We just won't just let it go. So the force of friction acting on this guy is going to be 5 newtons, and the force of friction acting on this guy is going to be 15 newtons. So how do we attack this? How do we look at it? We can look at it two different ways. We can look at it as a big block, M, being pulled by 50 newtons, and there's a frictional force pulling back on the whole block of 20 newtons, because that's 5 and 15. And we can look at it that way, and we can look at it individually. We can take a look at just M2. We take a look at M2, and we get a free body diagram that kind of looks like the normal, the force of gravity. We've got T2 is pulling on it, and we've got a force of friction pulling back on it. And this force of friction is 15. So we can look at just this guy. There's the free body diagram. And we can also look at just this guy. This guy is a little bit more complex. This guy has a normal force, a force of gravity pulling down on it. There's a pull force, so we could go F pull here or T1. It's up to you. I'll just go F pull because I know those are the same. And there's two forces pulling back on it. Did you get both in your head? There's T2, and there's a force of friction. So that's how you analyze it, by looking at it, three different free body diagrams. And I can draw a free body diagram here of the system. So that's what we would do. And in each of them, we know the direction is this way. That's what's winning. And if this was a free body diagram, there we go. That's what's winning. So we're going to attack the system first. That's this one. I'll call that the system. And the mass of the system is 10 kilograms. So we write down Newton's second law. Sum of the forces equals F net, which equals MA. And that's going to be the pull minus the force of friction is equal to MA. And the pull is 50. The force of friction is 20. The mass is 10. And we have to get A. You can see that A is going to be 3 meters per second squared to the right here.
Number 7.
Okay. And then we go look at these ones over here. We write down Newton's second law. Second law. So we have T2 here minus the force of friction is equal to MA, because that's what this diagram says, T2 minus the force of friction. And we don't know T2, but we know the force of friction, 15, and we know the mass of this guy, 8, and we know the acceleration, it's 3. We've got the 3 over here. So T2 is going to equal 24 plus 15. So T2 is going to equal 39. Now, if we look at this guy, we know everything. In fact, we know all the unknowns now. We know the acceleration and the tension force here. But we can also take a look at this and check it all out. Okay, we can use this as a check because we have all these forces. So we got the sum of the forces is equal to F net is equal to MA. And therefore we get the pull force minus the force of friction is equal to, no, I forgot another one. Minus T2 is equal to MA. So I'm going to solve for T2 again because we have everything here. So I'll just solve for T2 or just check to see if it's equal. How about that? We check to see if it's equal. The pull force is 50. The frictional force here is 5. The tension force here is 39. And that's going to equal 2 times 3. Does that work? 45 minus 39 is 6. And this is 6. So it does check out. It's nice. Now the question is, here we go. How do we do a vertical one? There's no friction here, but there's a pull force pulling up on it, which is going to be the same as the tension here, right? Whoops. Which is going to be the same as the tension because there's no objects in there to segregate it, separate it, and split up the forces. So that pull force is pulling up. There's a mass here with gravity pulling down, a tension force, which is also pulling down an M1, and another force of gravity here, and tension's pulling up. Which direction is T2 here? Along the rope, up and down. So how do we handle that? Well, we can look at it as a one big system. We can look at it as a pull force with one big block M. And then there's a force of gravity pulling down on it, and this is the pull. And this will be M1 plus M2. Or we can look at it and we look at it as M1 with a pull force up and a tension force down, that's T2, and a force of gravity pulling down on M1, because there's a force of gravity pulling down, this tension is pulling down. And then we also have to look at M2, which is, there's a pull force? No, there is no pull force on there. This pull force is attached to this guy. There's no pull force pulling up on this guy. So there's only a T2 pulling up on it, and then there's a force of gravity pulling down on it. Okay. Okay, let's put some numbers in here and see how it all works out quickly. Okay, let's just say you're pulling with 90 newtons, and this guy's mass is again 2 kilograms, and this guy's mass is 8 kilograms. So if we look at the system here, why do I call it the system? Because we're just creating all the masses, make one object and make it just a pull. We're pulling up here. The sum of the forces equals F net equals MA. The pull force minus the force of gravity is equal to MA. And that's the pull force minus mg is equal to MA. So the pull force here is 90 newtons. The mass is 10 kilograms. This is 9.8, and that equals 10 times A. Okay, so this is interesting. This becomes a negative, because this is 90 and this is 98. So this is going to be negative 9.8, and that's equal to 10A. So A is going to equal negative 0.98. And what does the negative represent? Well, I said the pull force was winning. It's not, because it weighs more than I'm pulling with, so it's actually going down. So I made a mistake. Do I have to erase all this? No. I'll just go, it's negative, then I rewrite it down here. It's going to be 0.98 meters per second squared down. Everything's fine. except that I'm going further and further right every time I write. Okay, so let's just move this guy over to here and let's work on him. This guy has a sum of the forces is equal to F net, which equals MA. And that's going to be, oh, it's going down. I'm going to say this one's winning, because then I now know. So the force of gravity minus T2 is equal to MA. And the force of gravity is mg minus T2 is equal to MA. And this is going to be 8 kilograms times 9.8 minus T2 is equal to 8 times 0.98. So this is going to bring the T2 over there. It's going to be T2 is equal to 8 times 0.98. And that's going to be a negative. And I'm going to add 8 times 9.8. You just do the math. If you don't follow me, just do the math. Greetings, by the way. Thank you, calculator. So we'll go 8 times 9.8, 78.4. Subtract 8 times that. Subtract 8 times 0.98, which will be 70.56 newtons is the tension force. Dun, da, da, da. You got it. And we can go on. But what's this one for? Well, we can use this as a check. And you don't have to, unless the question asks you to do it. E equals MA. So the two winning forces are T2 plus the force of gravity, and the losing force is F pull. And that has to equal MA of this object, of this guy. So T2 well, let's just leave it as T2. Let's just undo all my scribbles there. T2 plus mg minus F pull equals MA. So T2 is 70.56 minus plus M, which is 2, times 9.8, minus the pull, which is 90, has to equal 2 times, the acceleration is 0.98. Okay, so let's just pull up the calculator and check on both sides. 70.656 plus 2 times 9.8 minus 90 is going to be 0.16. And does that equal 2 times 0.98? What did I do wrong? What did I do wrong? Okay, let's see if I can find a mistake here. Let's start from the beginning. This is 98. 90 minus 98 is 8. This is negative 8. So the acceleration is negative 0.8. So the acceleration is 0.8 meters per second squared down. So it was good. This didn't check out. And because it didn't check out, I was able to find that I had made a mistake beforehand. Oh, it's so nice. It's not nice now because I have to change everything, but it's not that bad. Let's just make this as 0.8, and this, I'll leave it in red there just to show that I'm wrong. 0.8, so this tension is not that. T2 would have been 78.4 subtract 6.8, 6.4. So this is 72. That makes much more sense in my brain. So we do 72 plus 19.6. Oh, sorry. 72 plus 19.6 minus 90 is equal to, okay, 72 plus 19.6 minus 90, 1.6. And that does equal 1.6. So my check works. I'm happy with these answers now. Hey, I taught you a lesson. I taught myself a lesson. Careful with my math. And maybe you guys spotted it as I was going through. Put it in the comments if you spotted my error before I did. Or as I was doing it, you were going, oh, this is going to be good. Mr. Crow's going to crash and burn. Okay, anyhow, that's how you do those. It's pretty cool. The other one to think about, and I'll put another video up right away, a link to another video, is what happens if you have a block on a surface and it's being pulled along, but we have a pulley, and the pulley has another block pulling it down. There's our table or our surface, whatever. This block is pulling, and this one is going to drag back because of the frictional force. The purpose of the pulley is just to change the direction of the rope. So this tension is pulling up here, call it T1, and that tension is also the same tension that's pulling along there. Just change the direction of that tension. So there's no pull force. This is the first one of the other two that had a pull force. There's no pull force. This is a force of gravity pulling down on it, and the force of friction pulling back on it. But the force of friction is only acting on this one, and the force of gravity is only acting on that one. So if we looked at the whole system, we would have the sum of the forces is equal to F net equals MA. We'll call this guy number 1, that's number 2. We'd get the force of gravity of number 1, subtract the force of friction of number 2 is equal to the mass of the system, which is M1 plus M2 times the acceleration. And away we go. The system is the only difference, because this one just has a free body diagram like the one above. This one has like a free body diagram like 2 above, and away we go. So I'll put another link in right after this because this is getting to be a long video, and you'll have to take a break, like I should. See if this uploads. Anyways, thank you very much. Subscribe, like the video, comment below. It's so quiet. You guys don't respond. Yes, I see your hand up. Yes, you have a question? Okay, I'll answer that.